Hello, my name is Laura Winalski, and today I will be discussing the April 11th presentation by Dr. Stephen Carroll from California Institute of Technology and his hypothesis with his graduate student Jennifer Chen. The topic was origin and the evolution of the universe. I found this presentation to be particularly interesting because previously I knew little to nothing about cosmology. I've always been interested in time, in space, the Big Bang, the evolution of the universe, but I didn't really understand the connection between all of it. So I thought it was really interesting that Dr. Carroll was able to come up with a hypothesis that brings evolution of time in the macroscopic sense and applies it to the past and looks at the Big Bang. So Dr. Carroll began by discussing what is time. He says that the concept of time is something so fundamental and so inherent into society that we don't even recognize that it's there. But he states that time is a label on points in the universe. He talked about how Galileo invented the first clock by measuring his pulse and comparing it to a swinging pendulum in a church. And so he says that we measure time using repetitive, predictable events, such as our pulse, such as the swinging back and forth of the pendulum for Galileo that represented the time of 1 second. And now we use the two hands on a modern clock. He says that, Dr. Carroll says that time and space are both ways to establish where you are within space of the universe. But the difference between time and space is that space does not have a direction. Time does. Time only goes in one direction, which he refers to as the arrow of time, and it's from the past up until the present, and then it points on into the future. He says that we are able to change the future by the decisions that we make in the present, but we cannot change the past. Once something has occurred in the past, it cannot be changed. This only applies, however, in the macroscopic world. In the microscopic world, specifically in the fundamental phenomenon, or basically the fundamental laws of physics, such as the second law of thermodynamics, the third law, etc. Things that happen in the microscopic world can occur in either direction. In the same amount of time, a reaction that occurs in the forward direction can occur in the reverse direction, but this only applies to the microscopic world. This specifically relates to the second law of thermodynamics, which says that in a closed system, entropy or disorder is always increasing. It's never decreasing. So things within a closed system tend to go from a state of order to higher disorder. This law makes sense if you think about it in terms of biology or a chemical reaction, really any macroscopic event in a closed system. But this doesn't quite make sense when you think about our universe. Clearly, to be in line with the second law of thermodynamics, our universe needs to be in a constant state of increasing entropy, But this is a question that has stumped atomists such as Boltzmann and Lucretius since basically they're beginning to understand this law, and it's how and or why do you explain the Big Bang in terms of entropy. So Dr. Carroll and his graduate student Jennifer have proposed this theory that since we know that our universe is expanding at an accelerating rate, and eventually, millions of years from now, the universe will cease expanding, black holes will begin to collide with each other, and there will be nothing. But then that means that we are going in decreasing. If we're going to nothing, we are going in order of decreasing entropy. And so they have proposed the idea of baby universes. What they mean by this is that you have smooth and dense universes, as one such as ours currently, and they grow to an arbitrary size, and then they are ruined. And they all begin with their own Big Bang. So he says that our Big Bang that created our universe was not the only one. It was just a phase. But rather, you have these parent universes that yield baby universes that go on to yield other baby universes that have their own, Big Bangs and continues on. And this happens in both directions of time, forward and reverse, depending on your perspective and depending on how you look at it. The idea of baby universes is not so much as important. They're less important in the story, but the important point is to develop a model where low entropy is explained, not just merely postulated, and you can understand that in the context of the universe and the Big Bang. So then we can understand the direction of time, the arrow of time, and make sense of the growing universe, the expansion of the universe, entropy, and we can make a connection between the macroscopic and the microscopic world. I found this presentation really interesting, a little bit confusing at points because, again, I'm not really familiar with the concepts of cosmology, but I was very interested in it, and Dr. Carroll did a great job presenting it, explaining things as best he could. He gave a lot of history lessons as well. He discussed why Boltzmann's theory was not plausible. He took us through the history. He explained things in a way that we could understand. For example, the arrow of time, looking at aging or memory, why we can remember the past, but we can't predict the future, but we can't affect it. It was really interesting. I don't quite understand the physics, all of it, especially because we have been learning about electricity and magnetism, and in Physics 2211 we discussed kinetics and mechanics, not so much cosmology, but I'm interested in learning more, and I'll probably do much more research after Dr. Carroll sparked my interest. So that's my presentation, that's my review. Thanks for watching.